Hello there and welcome back. In this video I'm going to show you how I have added collision detection, and additionally I have created a text box on the top left corner of the canvas which shows the actual point. So for each pixel destroyed you get 1 point, and for each star destroyed you get 5 points. And the tricky part was first how to implement this point tracking. So what we would like to do is in the init function create the points equal to 0. This is kind of the easy part. What we have is the draw text function that is going to create a text on the top left corner of the screen with the let's say value of current points and the actual points that was passed there with an orange background or text color. And after that, what needed to be done is to check if the position of our box intersects or contains the coordinates of the pixels or the stars. So for the pixel part, it was kind of easy because all you need to do to detect if there was a collision, so the box holds the coordinates of the pixel, is to check to see if the x-coordinate is in the range of the self x and the self x plus 11, so the box is width. And if the pixel's y-coordinate is in the self x, self y and the y plus 11, so the box height. And of course, this should only be checked if the pixel is alive, so it's the red. Because if it's not, then we will set it to false, so that pixel will get the black color and we will increase our points. So as for the stars, it was a little bit tricky because they have this origo coordinate and those are intersected by 3 lines. And those 3 lines give plus, let's say, 2 pixels to the dimensions. And what I did was to enumerate every star I have. The x found and the y found will mark if any coordinate of the specific star is within our box. And after that, I have created these 2 for loops, and these are going to represent the coordinates of the stars. And apart from that, there is another for loop that is going to also represent the y based on the y coordinates and the x coordinates. So actually this covers a small box around the star, but that's good enough for the collision detection. And we will only care about the stars that are alive. So this was kind of at first what I wanted to implement here. But after that, I got the idea that if you play long enough, the screen will get empty. So I needed a way to generate new pixels and stars on the screen and to make them, let's say, not so obvious by the algorithm. So I used the randRange function from the random module. And apart from that, the tricky part was how to figure out the coordinates. So what I wanted is to, let's say, not create stars or pixels outside of my box. So I needed to figure out a way to mark the x-coordinate. And basically what I did was, let me show you. So I got the idea. Yeah, it's paint. So here we have our canvas. Here we have our small box. And if that small box is not on the edge of the screen, then I have 2, let's say, intervals I needed to inspect. Let me change this to green. So this is the first interval as for the x-coordinate, and this is the second interval. So I needed a random coordinate from this one, and another random coordinate from this one. And this resulted in appearing pixels all around my box randomly on the canvas, because they also cover this part. Come on! this part, this part, this part, and this part. And the same logic went for the stars too, with a little bit of, let's say, extra consideration. So what I wanted to do is check if the number of stars alive is less than the number of stars. So this way I make sure that once you destroy the star, another one appears. So the number of stars is kind of constant. The same goes for the pixels. And after that, what I needed to modify is my draw function, because I only wanted to draw the stars that are alive, because those are the ones about which we care. And of course, in the update function, this is also reflected, because we only want to calculate the intersecting points based on the status of the star or the pixel, so if they are alive or not. What may not be obvious from here is that this round range function takes a range of numbers, and this is based on the starting point and the end point. And the end point is the pixel width, which is the width of my canvas. And this is also going to be replaced by the height. Then, yeah, because that's what the y-coordinate is representing. So, are you ready to take a look at how this goes? So, basically, this is how the game looks like now. As I have said, we have the current position points on the top left corner of the screen, and the minute I start to move and destroy a point, you can see a new one appear. And my points are increasing, and the stars are getting destroyed, and new ones are appearing. There are many ways to improve this also. We could create a finite game based on a constant amount of stars, and you could measure the time it took to collect every point and so on. Basically, this can be modified, and only by experimentation you can have a pretty good picture as to what you can do with this. So basically, this is what I wanted to show you in this video. Thank you for watching.